Computer Programming for Kids, Step 19, Retrofitting and Repurposing, or Refactoring, our code. Continue. We are in the middle of retrofitting or refactoring our code to make it able to run any set of multiple choice questions it is given to work with. Any CSV file with the right type of data in it, that is. Perhaps in this case, repurposing is actually the more accurate term. Since we are reading the questions and answers to display on the screen from the class list, MCC list, we won't be hard coding any of those values as we did earlier with the age guessing extravaganza. We will read the questions and answers from MCC list as we loop through it, splashing the first question and its candidate answers on the screen when the app starts, and then each next set, a question and its three candidate answers, each time the user clicks the next button. Note, some people call it a form, some people call it a screen, some people call it a window. You can call it whatever you want to, I guess, just don't call it late to the dinner party. I normally call it a form at design time in Visual Studio and a screen at runtime when the form is live. By the way, you can also call what some people refer to as a computer screen, the physical device, that is, a monitor. But every time I hear that word, I think of this guy. And then it shows a picture of a monitor lizard with a very funny-looking tongue. And it gives me the fantods. We left off step 18 right after commenting everything out of the load next batch method. Let's get back to that. But before we write the code for that method, let's first discuss just what it is we're going to do in order to prepare for that. MCC list, the list that holds instances of multiple choice class, is populated once the user selects a file name from the combo box. This is what we will do with each click of the next button after some cosmetic and gatekeeper code. 1. Read the set of values from the next multiple choice class instance stored within MCC list. 2. Populate the screen with those values, specifically the question label at the top and the 3 radio buttons. 3. Update the question number label, the one that says question in of in at design time. 4. Update the progress bar by extending its colored bar out the appropriate amount or distance to the right. 5. Update the percentage label, updating the calculation based on how the answer to the last question affected it, either increasing the percentage correct if the last question was answered correctly, or decreasing the percentage if the answer selected was wrong. Finally, once we have reached the end, that is, the last question with its answers have populated on the screen, we will disable the next button. Normally, we re-enable it each time the user selects an answer, but not on the last question. First, though, and this is bothering me, so I've got to take care of it before we move on. Let's rename the label at the top of the form from label 1, that default name is boring and non-descriptive, to label question, LBL question. You remember how to do that, right? If not, rack your brain like a billiards table. If that doesn't work, read previous steps to be reminded of how to do it, or Google it. Okay, never mind. Let it go, I'll tell you. Click the label and change its text property in Visual Studio's Properties pane at the lower right of your screen. The moral of the exercise, always name controls or even components such as labels as soon as you put them on the form, at least if you are going to reference them in code. Note, as you may have surmised from the above, there is a difference between controls, which the user interacts with at runtime, and components, which are usually visible but not interactable. If I'm a neologist, so be it. So, for example, buttons, combo boxes, and radio buttons are controls. You can click them or select them, whereas labels are not. They are components. To get started in our preparation for this extreme makeover of the code, add this to the area at the top of the form where the variables and constants are declared. And it shows a new integer being declared, an int, multiple choice class index, and it has a starting off value. It's initialized in programmer speak, at -1. This variable is incremented by 1 as we go through the questions to keep track of which record or class instance we are currently accessing from MCC list. We will do that this way. Put this in the load next batch method, which is called by both the next buttons click event and the combo box's selected index changed event handler, which fires when a user selects an item from the combo box. And it shows the multiple choice class index integer variable being incremented. This increments the value of that variable, taking it from -1 to 0 when the load next batch method is first called. We gave multiple choice class index an initial value of -1 so that when it is first incremented, it will be at the desired value of 0, so as to access the first instance of the multiple choice class at index 0. Let's now go through the to-do list above, one at a time. 1. Reading the members of the current multiple choice class instance, and 2. Populating them into our form happens simultaneously. This is done in the load next batch method, as it is called. First by the combo box multi-choice file _selected index changed event handler, and also thereafter each time the next button is clicked. Here is the pertinent part of that. And then it shows that method, load next batch, which is pretty long and handles several of the things we're talking about. And there's comments which show a number which correspond to the numbers that we're going through right now. To quiet the barking hounds and prevent future ones from even getting a start on flapping their jaws, add these entries to the variables at the top of the form. Then it shows 4 new variables that we need to have because we're using them in the code. 3 ints or integers and 1 bool or boolean called freeze answer, which will be interesting. We'll talk about it later, of course. In the second if block above in the code, which you can see in the newsletter, which starts out if multiple choice class index is less than number of questions, you see that provided multiple choice class index has not been incremented beyond the point where there are instances of multiple choice class in the list, label question and the 3 radio buttons are assigned new text values. Makes a lot more sense when you look at the code. A lot easier to understand. 3. The first thing that happens inside the try block is that the update question number label method is called. We need to refactor this method. It is currently, and it shows it as it is at present. Just 2 lines of code in that method. The hard-coded 10 needs to go, as there may be a different number of questions. So this code now becomes, and it shows the updated method with that changing. It's no longer 10. It's got 2 placeholders instead of 1. It's got a new line of code incrementing the variable current question number, and it uses that as the first replacement value, and number of questions as the second replacement value. So in the first line of the code, this code has changed so that there are now 2 placeholders in the string constant. The second line, the value of the current question number variable is arrived at by adding 1 to how many questions have already been answered. Third line, which wraps around to the 4th on the page, the current question integer and the total number of questions integer replace the placeholders in the string and are assigned to the question n of n label, so that it reads question 1 of 10 the first time it's shown, or question 1 of 13,620,057 or whatever. 4. After the question n of n label being updated, and just prior to the label and radio buttons being updated, the updating of the progress bar value, the length of the colored portion, takes place in the code here. And it shows the code that does that. This code is basically saying if the progress bar isn't already maxed out, colored all the way out to the right edge, extend it in that direction by adding the value of step amount to it. So if the current value of the progress bar is, say, 52, and the value of step amount is 4, indicating that there are 25 questions in the CSV file, as 25 times 4 equals 100, the value property of the progress bar will change from 52 to 56. 52 plus 4. And the colored portion of the progress bar will inch a little to the right. Now, to update the percentage label, create the following method. It shows that method called update percentage correct. Before updating the percentage, we need to know whether the user's choice was correct or not. The first part of the code above takes care of that by calling the answer is correct method. Note that this method returns a bool. That is, it returns one of two values, either true or false. If the currently selected answer is the correct one, the answer is correct method will return true. Otherwise, it will return false. Here it is, covered in glory in all its splendor. And it shows that method. The answer is correct method. Answer is correct basically retrieves the correct answer value from the current multiple choice class instance and determines by means of the if-else block which answer is correct. Remember that multiple choice class has a member named correct answer, which holds an integer value indicating which of the three candidate answers is correct, either 1, 2, or 3. This code determines what the correct answer is by querying that value. Then, in an if-else section, it determines which answer the user selected. When the two are identical, the correct answer and the selected radio button's value, that is, true, is returned to the caller of this method. Otherwise, false is returned. Notice how, in order to save space and to prove a point, the if-else block in the answer is correct method above is formatted like this, and it shows the if and the else-if statements all on one line each. You may have expected it to be formatted like this, and it shows it as we've seen it before, with it spread out over several lines. The point is, they are really both exactly the same thing, except for their appearance. To the compiler, though they are identical, the compiler doesn't give a whip for formatting or appearance. Use whichever style makes more sense to you. Getting back to the update percentage correct code, if the answer is correct method returns a value of true, the correct answer's variable is incremented. Then the percentage is calculated like so, and it shows the code for that, and finally added to the percent label, and it shows the code that's doing that. Note, the percentage correct variable introduced above is of data type double. Double, don't look now, but I just double. Oops, I almost did it again. As a specialized subtype of the more specific float data type. Say what, you might say? A float class of numbers is called that because they are numbers that float in the sense that they contain decimal points. It's the decimal point that can float. It can be 3.14 and so be approximately 3 1/7. If you float the decimal point to the right, it is 31.4. If you float it to the left, it is 0.314 or 0.314, same thing. Do the floaty pokey and you turn yourself about. You don't get that joke, do you? Too young, doubtless. Anyway, we are using a double, a special subtype of a float here, because we want to display the percentage of correct answers. And the percentage will not always be an even 10.0, which could be displayed as 10. In fact, that will hardly ever be the case, unless you do happen to have exactly 10 questions, or a number of questions exactly divisible by 10, with no remainder. In fact, as you may have noticed, I had to convert the integer values, correct answers, and questions answered to doubles to get the percentage calculation to be accurate. If calculated as integers, the value was always either 1 or 0. Thus, it became 100% or 0%. The code to calculate the percentage is interesting, yes, even if I do say so myself. However, woo-wee! I don't know about you, but my brain is frazzled and my coding fingers are cramping up and about to fail of their office. Let's call it a session, or a lesson, or a step, and say sayonara, adios, farewell, and auf Wiedersehen. Until the next exciting episode of Computer Programming for Kids, where we will discuss why I think that percentage calculation code is interesting, and also show you how to handle coming to the end of the file. Until then,